the major thing today is geometric progression, but I said let's make a recap of what we have today. Okay, so let's make a recap. We said arithmetic progression. Please, if you are coming, mute yourself. So that there won't be too much noise. So we said AP, arithmetic progression, and geometric progression, they are the types of sequence that we have. We can also call it arithmetic sequence or geometric sequence. Now, another name for arithmetic sequence is also known as linear sequence or linear progression. They are the same thing. So if you come across a sequence, how do I know that this sequence is arithmetic? That is, how do you know? We said in the last class that it will always have a difference or addition. That is, if you have the first term, the second term will be what? You will discover that there is a difference between the first and second term, the second and the third and the fourth. So when you are having such thing, if it's increasing or decreasing, but that difference or that increase should be what? Should be constant. So when they are constant, are you getting it? When they are constant, it means that it is an arithmetic progression. When the increase or the decrease is constant, we'll say it has a common difference. It has a common difference. And based on that, we will now say that that sequence is an arithmetic progression. Are we getting it? So when we have a sequence that has common difference, we'll quickly say yes, this sequence is arithmetic or linear progression or linear sequence. It's the same thing. So we can calculate any term of that sequence or that AP. We call it, you abbreviate it AP. You can do what? We can calculate any term missing in that sequence. And how can we do that? We use what we call the n term. The n term, which is what for AP? Who can remind us? Just one person. Before you talk, please raise your hand so that everybody will not be talking at the same time. If you want to remind us the formula for n term, can somebody raise hand? Unmute yourself and tell us.
The formula for finding n term. Can you hear me?
I can hear you, sir.
A plus into brackets n minus 1d.
Say it proper. Say it well.
N term of an AP equals A plus into brackets n minus 1 close bracket d.
Okay, that's very good. That's very good. You've tried. Can you mute yourself? So now with that, what he just said is what? Let's write it down. I know we have it in our notes. Abi, Tn equal to, that is A plus n minus 1. We close brackets. Then you have d. This is known as the n-term formula, which you can use to get
You can't hear anything, ma.
You can't see it. Okay, can you hear me now?
Yes.
But can you see my board?
Yes.
Okay, so that's the formula for the n term. Are we there? So, and we solved how many questions? We solved like 2 questions. Okay, then we also consider the sum of AP. I told you they are 2. So they are 2. One is what? One is when the end term, the last term. The last term in a sequence is known. When the last term is known, for example, that is when we have a finite sequence where you have 1, you have 3, you have, let's say, 4, 7, okay, just like that. And then you now have, let's say, 54. So in this sequence now, this one is known as the first term, which is the same thing as T1. This one is known as T2. Just like that. You see, this one is known as the last term, or the T term. Are you people getting it? Hope you saw what is on the board.
Yes, ma'am.
So with that, we can now say yes, we have the last term. But since we have the last term, if we're asked to sum the terms, remember that each of these numbers, say 1, 3, 4, 7, they are called terms. T-E-R-M. They are called terms in a sequence. So if they now say you should find sum, that is, what they are saying is that you should find the series. Series is the same thing as what? Sum. That is, you are adding 1 plus 3 plus 4 plus 7. 1 plus what? 3 plus 4 plus what? 7. Do you understand? Plus that, yeah. until what? The last one. Okay? So that's adding of those terms in a sequence is what we call series. So if they say you should find the sum, we have 2 sums, formula for the sum for AP, and we did it last time. We have who can raise up his hand and please remind us the 2 formulas we have. The 2 formulas we have. Somebody should raise up the hand and tell us the formula you are. Yes.
You gave us 2 formula. Yes. 1, if we have infinite sequence, the formula will be Sn equals n over 2 bracket 2a plus another bracket n minus 1 close bracket d close bracket.
Exactly. That's a very good one. Yes, another person, you can unmute yourself, then another person should tell us the second formula and the condition whereby you can use the second one. Okay? Wait, that first one you said, hello? Oluwatobi, that first one you said, you said Sn equals to n over 2. Open bracket 2a. Plus n minus 1 close bracket d close a bigger bracket. When do you use that?
When there is infinite sequence.
Exactly, that's correct. When the last term is what?
Is unknown.
Is unknown. Beautiful. Then somebody now tell us the one on the board. What we have on the board now is when the last term is known. So what is the formula for that?
Yes. Should I say it?
Somebody else now. Is Afolabi Favor not there? Is Tokpa not around?
Not sure.
Yeah.
Oh yeah, oh. I'm waiting for you, Auntie.
Ma, for what? Ma, I just entered the class now.
Why you go? You are coming in, leaving, leaving. What happens to your network?
The network is shifting, so I've changed location.
Better. Give us the sum of a AP sequence when the last term is known. The formula for calculating the sum of AP sequence when the last term is known. We did it last week, right?
Yes, ma'am. The formula is N all over 2 open bracket A plus L close the bracket.
Exactly. That's good. Very, very good. So now with that, if you see any question, you should be able to do what? You should be able to solve. So but today we are going to do what? We are going to talk about geometric progression. Okay? So when we talk about geometric progression is when we discover that the ratio of each term, that is, if you find the ratio of what? The first term to second term, the third term to fourth term, or the ratio of any of the term in that sequence. If we find the ratio, we discover that those ratios are common, then we call it common ratio, and that which shows that that sequence is a geometric progression. So based on that, if you divide any of the sequence, and you discover that the result is a constant, and that constant is common, then we can boldly say that that sequence is what? Is a geometric progression, or geometric sequence, or we say it is exponential sequence. So we can call it how many names now? We can call it exponential sequence, geometric progression, or geometric sequence. They are still the same thing. Okay, when we find the ratio on each term, the ratio of, let's say, term 2 to term 3, or term 3 to term 5, or term 5 to term 10, and then they give us the same ratio, the same constant, we say it is geometric progression. So is that clear now?
Yes.
Okay, have you written it down, or you still want me to write it for you?
I have written it down. Yeah.
Okay.
Yeah, there.
Okay.
Right.
Sir?
Can you write it down for us?
That will take time. Or if you did not come to class early now, you can write it by yourself now. Okay?
Yes.
I should still write.
No, man.
So what I want us to do is to solve just like AP2. Geometric progression also has its own n term. That is what you can use to show you what you can use to find any of the terms. Wahid Adebayo. Okay, let's move on. We have the n term for AP. That is A R n minus 1. That's the formula for calculating any of the terms. And so, just as we know that the one for AP, this is for GP, geometric progression. And so you can use this to calculate any of the term in a question. And so that won't give you problem. So, but the only thing with this is that you must be conversant with indices. At least the elementary part of indices. So once you have, that is the basic knowledge you should have in order to solve geometric progression. So with that, let's pick a question. Let's pick a question that we want to solve. So let's pick example 1. Example 1, let's be writing the second term of a GP. The second term of a GP. The second.
Ma, just dictate. Don't waste your time writing.
Okay. The second term of a GP exceeds the first term. Exceeds the first term. Are we there?
Yes, ma'am.
So with that, have you written it?
Yes, ma'am.
Exceeds the what? The first term by 4. And the third term exceeds the second term by 12. Full stop. Did I move on?
Please, exceed the third term exceed the second term, or what did you say?
The second term of a GP.
Yes.
Exceeds. Are you seeing the spelling?
Yes.
Exceed the what? The first term. Have you seen it? The first term by 4. And the what? And the third term. And the third term. And the third term exceeds. The third term exceeds. Are we there?
Yes.
Exceeds the second term by 12. Have you written that?
Yes.
By 12, full stop. Find the fourth term. Find the one. Find the fourth term. So have you written it? I want to change the board so that will solve. Have everybody written it?
Yes, ma'am.
Okay, so now let's go for solution. So the solution we have, what are we given in the question? I told you if you want.
We're giving the difference between the second and the third term, the second and the first term, and also the difference between the second and the third term.
They didn't give us difference there. Look at the question very well. Is there difference in GP? What do we have in GP?
Ma, we're giving how the second term exceeds the first term.
Explain it like that. Write it down. That is the T1, the T2 is equals to what? The first term, Abi. The first term, it exceeded. When it exceeds, it means it's plus what? Plus 4.
Let's go.
Abi? And we know that this first term is the same thing as A. Then the second statement says what? That the third term exceeds the second term. It exceeds the second term by what? By 12. That's all we're given, Abi?
Yes.
When you say exceed, when you say increase, when you say extended, all they are saying is another way of saying addition, increase. Are we getting it? When something exceeds, so that means if it's in position 1 and it moves to position, let's say 10, and they said that movement is equal to certain one thing. So that means that is, if you want to get the last position, it will be addition of where he's standing and the how the thing has moved. Abi?
Yes.
So that will be S2 equals to that. And then the next time we should find the fourth term. It means before you can find the fourth term, you must know 1. The first term is not given. 2, you must know the common ratio. It is also not given in the question. So, but the information they gave us, can it give us the A term and the common ratio. Yes, it can. And so how are we going to get it? With these two statements. So now let's start. We'll start by saying our T2 equals to what? T1 plus 4. And so this T2, using our formula of what? Of enter, that is equal to, sorry, somebody wants to join. Let me see if I can allow the person. But the network of that person is not really... Okay, let's continue. So let's see. We have that is, we have A R N minus 1. Okay, minus 1. Let me put it up there. And so if that's the case here, it means our T2 will be what? Will be T2. Sorry. What will be our T2? Our T2 will be A. Our T2 will be A, right? It will be A R raised to power 1. That is 2 minus 1, Abi. 2 minus 1 equal to our A. T1 is A plus 4. So this will give us again A, Abi, 2 minus 1 is 1. And this is equals to A plus 4. So with this, I collect like that. AR minus A equals to what? 4. This implies that my A is common, isn't it? I have R minus 1 equals to what? This is equals to 4.
Oh.
And so in this place, I can't move again. All I will say is that what? Or can I want to change the board. Have you written it down?
Yes.
Yes, ma'am.
Yes.
Okay, now. So
Okay.
what we have there is what? Our A, open bracket, R minus 1, close bracket equals to what? 4. Am I right? Am I right?
Yes.
Am I right?
Yes.
Yes, ma'am.
So this will give me A equals to 4 over R minus 1. So I will call this equation 1. So the second one, what's the second equation 2? Yes?
That'll be T2 plus 12.
That's T2.
Plus 12.
Okay, plus 12. T2 plus 1. Somebody should quickly solve that one. The way I did this one. I've gotten it. The way I did it. And so with this, you know that one was what? T what? You know you have it with you. So that's why I'm asking you.
T1 plus 4.
No, the second statement.
T2 plus 12.
T what?
2 plus 12.
The second one is saying, what's the second statement? T2 equals to T1 plus 4, okay? So that's T2.
The second one is T3 equals T2 plus
That's
12.
what I'm asking now. You know I don't have it. I just wrote it for you people.
Yes. Sorry.
Please tell me the right thing so that we won't make mistake.
T3 equals T2 plus 12.
Thank you, sir. So we have T3 is equal to what?
T2 plus 12.
T2
Plus 12.
plus 12.
Yes.
Now this is our T1. This is A R raised to power 2. You know how I got my 2?
Yes.
Then this one is what? A
So
Sir?
it is still how you got the 2.
What's the formula for enter for AP? For GP, sorry. Oluwatobi, who asked the question? Somebody asked the question.
The formula for GP. The end term.
Yes.
It equals Tn equals AR raised power n minus 1. Yes.
Okay, that how did we get AR2? A raised to AR power 2. How do we get that one? That's what he's asking.
The T3. So the end there is 3. So subtracted 3 minus 1 equals 2.
Is it clear now?
Yes, ma.
Okay, so we have AR2 minus AR equals to what? 12. What's common in this equation now? Are you seeing my board? What's common?
AR
is common. So we have R minus what? 1. And this is equal to what? 12. Do anybody have question? Any question?
I understand.
Hey. Okay. Okay, we have 3 A3 equals to what? T2 Abi plus 12. Now if I want to get a T3 is equal to AR 3 minus 1. Did you follow me to that point?
Yes, ma.
And this is still the same thing as AR raised to power 2. Is it clear now?
Yes, ma.
Then I want to get T2. My T2 is what? AR 2 minus 1. Abi? Because what we're using here is Tn is equal to AR n minus 1. So with this, what do I have here? I have AR. So substitute T3, T2 in that statement that we're given. So what are we going to have? You have T3 equals to T2 plus 12, Abi? Then what is our T3? Our T3 is AR raised to power 2 is equals to A raised to power R. AR, thank you, plus 12. Tokpa, is it clear now?
Yes, ma.
Any other person that have problem with this? Let's talk. Okay? Can we move on now?
Yes.
All right. So we can now get another board. And then that means we have AR squared minus AR equals to what? 12.
Yes.
And I ask, Tokpe, what is common here? What is common? Did you see anything common there? In the left hand side of the equation.
AR.
AR is common. That is AR. Open bracket. What will I have here? Yes. If I pull out AR from AR raised to power 2, what will remain?
It's question for everybody.
Tope, what will remain? Tope no longer in the group.
She's there, but she's muting herself.
Tope, unmute yourself and answer me.
Ma, you said if we remove AR
Mm-hmm.
from the equation, then it will remain R.
Please, Tope, were you sleeping?
No, ma.
Now, if you remove AR from AR, what will remain?
R minus 1.
Yeah. Who else don't understand? You know what you are saying now, means we have to go back to elementary mathematics. That is the maths you did in primary school.
Ma, AR minus AR, it remains nothing now.
No.
If I remove Tope, look at
I
you.
don't get the question. I understand it's to that AR raised to power 2 minus AR equals to 12. I understand it's to that side. But the question you asked is what I did not get.
Who can help Tope? Who can help her?
Can I try?
Oh yeah, try.
Please do.
Okay. The question says AR squared minus AR equals 12.
Yeah.
Right?
Yeah.
So the common letter there is AR, right?
The common factor
So
is
the
AR.
common factor there is AR. So to separate them, you have to like divide, or yes, you can divide.
Exactly. What it means is
So,
to divide.
Yes. So you put
like,
AR outside the bracket, then R.
Okay, let's do it as if we're in primary 1. Let's do it. This,
Yes.
you have AR squared. Abi, I want to bring out what is common here. I will divide by AR. If I divide by AR, what will happen? What will happen?
R will remain.
It will remain R, Abi. So that
Yes,
means if I pull out, sure you know that division and multiplication are related.
Yes.
So it means if I pull out AR from this, I will have what? R will remain. If I pull out AR from AR, what will remain? Tope?
1.
Tope, you are not sure. It's just as if you are sleeping. Is 1. Because if I multiply AR by R, what will it give me? AR squared. If I multiply AR by 1, what will it give me? AR. Can we move on now?
Yes.
Good. Thank
Yes,
God.
ma.
So we now have AR is equals to what? Or will it? Yes, is equals to, let's make it simpler. Plus 12 over what?
Minus 1.
Or don't let me make it complex for you. So let's stop here. Okay. So what will I call this last one now? Equation 2. Abi, it will be equation 1. Equation 2.
Equation 2.
Good. Now in AP and GP, I'll call this equation 1. Equation 2. This is equation 2. Okay, so with this, what is in our equation 1 before? You know, GP is not as simple as AP. You know, last week you were all
In the equation 1, A equals to 4 all over R minus 1.
A equals to what?
Equals to 4.
4
all over R minus 1.
Okay, all over R minus 1.
Minus 1.
But before that, we have something like A into bracket R minus 1 equals
Yes.
to what? 4, abi?
Yes.
This will be easy to work with. Is that clear? If you divide it, it will be complex somehow for you. But for some people can still work with it. But let's work with this one so that we don't waste so much time and you will understand it easier.
Our class is about to end, ma.
Yes, I know. I'll create another link. Do you
Okay.
understand? So with this,
Yes, ma'am.
I know GP will give us problem, but no wahala. We can still understand it. That's why I'm taking it slowly.